Michael,
Hey, good afternoon, Jan. How do you do?
doing fine. What about you?
Very good. Yes, doing quite well. Enjoying a bit of bit of cold weather here in Dallas. Starting to feel a little bit like winter.
It was very cold a few days ago, but in meanwhile, it got a little bit warmer with rain. But
Hmm.
for the moment, the sun is there, so it's all right.
Excellent. All
Yeah.
right. Yeah.
I saw
So.
as
Mhm.
usual you have been doing some nice work.
Yes.
I went
Yes.
I went on holiday for a week
Uh
for
huh.
my wife's birthday, so that means
Oh.
nothing done. After that, had to catch up work, but I saw your recording,
Yeah. Excellent.
and that and okay, I could make some time to view that and to review it because one time is not enough.
Yeah.
But it was quite dense, but it was very nice. Um, and the first time I thought it's exactly the same as what was in the book,
Ah. Yeah. It
chapter
is a little
chapter
bit
four,
different. Yeah.
but no, it's a completely different approach, and especially the fact that you add the queries, the evidence, and the invalidation
Right. Yeah.
is very nice.
Yeah. Yeah, thanks.
Um,
Yeah, it starts off with CRDTs, which I do talk about in the book.
mm,
Uh, but uh, but yeah, I just wanted to make sure that people coming to the video could be able to start right from the beginning
mm,
and get what I'm talking about. So yeah, I had to do a bit of review there. But yeah, uh, the idea of evidence, um, and especially the feeds concept. That kind of evolved after publishing the book, um,
mm.
and so yeah, that really solidified. Okay, this is truly the mathematics that we're implementing with Jinaga, and this is what it truly unlocks. So yeah, that needed to be captured.
Yeah, because that feed that was always a big question for me
Mm-hmm.
when we discussed the interface. Um, but now at least it's a little bit clear. But actually, you gave an example with the app and then a server
Mm-hmm.
and then multiple intermediate computers.
Right. Yes.
And finally, it reached an application of somebody who wants to transfer money to you.
Mm-hmm.
So it issues an update, transfer money, and the update ripples back all the way to your application to update your state.
Mm-hmm.
But all these intermediate, so your application, the server, and all these intermediate computers, what was that? Were that other servers?
Yes, yeah, that's other servers. So just in abstract, I was talking about the different topology that you might put in place if you're implementing a distributed system. It could be microservices. It could actually just be good old school distributed systems from the last couple of decades. And so, like one of the examples that I just kind of threw out there verbally was there might be an index over here that's doing some searching, um, and so um, it ends up it's not um, yeah, in that particular example it wasn't interested in the same query that you were interested in. Um, So maybe it's just like an index of accounts. It's like I don't care about balances. I don't care about transfers. I'm not issuing those queries. But your application is issuing those queries, and specifically those queries for your accounts. So it's like here's the specification. Here is the givens that represent. Okay, I'm starting from my account, and the queries move out from my machine and then ripple through the network. So so yeah, it's just demonstrating that whereas today we have to think about as I deploy different machines, in order to make them work, I need to also deploy different queues, and then I have to write code in the software that's running on this machine to make sure that it posts this message to that queue, and then on that machine to make sure that it subscribes to that queue. And so all of that is what I'm saying is now completely automated, because
Yeah, but
solve this equation and it tells you what it needs to do.
that means that all the queries of all the clients are propagated to all the other systems.
Yeah, so what I envision is that you will design the connectedness of your distributed system um, with that intelligence of over here in this region, this is a backend for front end for mobile applications. So I know what kind of data is going to be flowing through there. I just don't have to be explicit about you know writing to a queue and subscribing and all that stuff. But I know that it's happening over there, and over here I know that this is calling an API. Maybe this is actually interacting with a particular bank, and then this system over here is interacting with a different bank, um, and and then different services that are located elsewhere. So so basically, I foresee that when you build a distributed system, you just put each one of these kind of around the edge of your network, and then you'll put some replicators in between. It could just be all of these are connected to one replicator, and then that replicator handles. It's basically all of the information is flowing through there, and then going back out to just the ones that are interested in that information. Or you could get a little bit more intelligent about it and say that, I know that that these systems are going to have to talk more in a more direct way with these other systems. So I'll give them a common replicator, but then they don't have to talk directly for all of their different transactions with these other systems. So I'll give them a different replicator, and then I'll connect these two together. And that way you get information flowing with lower latency over here, and then low latency over here, and then every once in a while messages flowing between the two.
So in fact, every, let's say, user, every company with multiple users has its own replicator.
Yeah, that's actually a different topology that this supports.
The queries are processed in the local replicator. So it's the replicator has all the data available,
mm-hmm.
and pushes whatever you need towards your device.
Yeah.
And the replicators of the different companies, they replicate between them all the data. Is that?
Yeah, exactly.
One of the
So what I was just describing there was different functions within a distributed system that one company owns. But yeah, you're right to point out that different companies are going to be setting up their own topologies, their own set of replicators, and they're going to want very highly controlled interactions between their edge replicator and your edge replicator. So it's like, here I'm serving all of the requests for all of my employees and my customers, but then when I need to integrate with a partner, then I've got one replicator at the edge of my network. I put that in a DMZ in the network so that I can control access from the outside, and then I know that the queries that I'm going to allow from the outside are going to subscribe to just a subset of the information that's flowing through here.
That's also a possibility.
Yeah.
So you can really limit data flowing to your own people
mm-hmm.
based on their needs, data flowing to third parties based on their needs, and get data from third parties based on your own needs.
Right, exactly.
Yeah.
Exactly.
If we, for example, 3 different users
Mm-hmm.
In a company, they all have their queries. So the queries goes to the company server, and the server needs some data from a bank server, for example.
Mm-hmm.
That would mean that the company server knows all the queries of the 3 users. Is it able to combine that query in an optimized way to send a single query to the bank then?
That is a great question. I have not solved that problem yet. Um, so yeah, each of the different users are going to have a query that starts with, say, account, and so the given for each of the different queries is going to be different. This account, this account, this account, um, and so yeah, it might be yeah, you might want to say, okay, I want to go up one level. I want to start with the predecessor, and now, the predecessor is just the bank, and so now give me information about all accounts from these three. Um, that, yeah, I'm not certain how would be
I'm
best
not
to
even
express
sure
that
that
optimization.
it might be an optimization. I don't know.
Yeah.
Uh, I'm just wondering if we have a lot of queries coming from the same site, instead of propagating all of them.
Mm-hmm.
Somebody says that he's not participating.
Oh. Oh no. Okay.
Perhaps next week.
All right. Yeah. All right. Yeah. Yeah. I think that there is a way through that. That's um, yeah. So basically, um, what you'll just kind of get out of the box is that very detailed set of feeds, and so yeah, you build a system that way. You've got thousands of customers, and then you'll end up with with thousands of feeds, and um, and so yeah, there would need to be observability baked into the system so that you could say, oh, wait a minute, look, this is doing a lot of work that I know I could abstract. Um, so there's no information in the model just like that says that you are even permitted to abstract up one level, let alone that would be what you want to do. Um, Maybe the permission is in there because we haven't talked about distribution rules and authentication rules and how they play into this. But but yeah, if you take it to the opposite extreme and you've got a replicator that you use just for your executive team, and it's like, okay, I want to make sure that all of their communications are nice and fast. So um, yeah, so I just set up the network topology so that their machines and their mobile devices are connecting here, and then everybody else gets into this pool. Now they issue some queries, and the whole point is to have a smaller set of givens for those queries, and not flood that replicator with all of the traffic. So so yeah, I want a way to give people the option of creating these optimizations, and I think that can be done. As I think through, if somebody were to sit down and write a specification that's not in the application, um, you should be able to see. You should be able to just verify. Okay, this specification starts from a different given, but I know after this one step, it matches that other specification, and so and
Yeah.
so I know when I receive one of these queries, it's a subset of this other query, and so I can say, okay, I don't need to actually handle that one independently. I can just
Mm.
assume that it's being handled by this big one. Yeah, I see how that working.
I I need that substate or merging of two states. Um,
Yeah, yeah. At this
okay.
point, I don't want to do it automatically, but manual does manual with verification does sound
Mm.
quite feasible.
No, it's not something that I need urgently.
Mm.
So I
Yeah.
was just I was just thinking about it because you made that nice drawing with all the different servers.
Yeah.
I say, hey, that's gonna be
Hmm.
a lot of queries.
Yeah. Yeah. My friend
Uh,
at Improving, Tim Rayburn, he often says, make it a problem. So it's like we come to him with a, hey, we've got this concern. If this happens over here, what are we going to do about it? And usually it's, if this really good thing happens, like, hey, if we get, if we put this product out there and we get, 1,000 people, wanting this course, we can't scale that. We only have one instructor. Make it a problem. Go ahead and sell that course. Prove to me that you need
mm.
more instructors, and then let's go ahead and train those
And then we will
instructors.
find a solution.
Yeah.
Yeah. Um, oh, the Jinaga Academy, Jinaga Academy.
Yeah.
That was a nice.
Yeah, yeah.
That might be an idea for for your new business then.
Yeah. Yeah, I
Yeah.
um definitely see running this as a school. Um
Mm.
so so yeah, kind of start with the Janaga experiment is, hey, can I teach people enough of Janaga development so that I can verify that they're more effective, that we have better outcomes than we do without Janaga. Um, and and so in order to teach them just enough, starting with just a few videos. Um, but yeah, let's make this an entire Janaga Academy where everybody has access to these few videos, but then you you demonstrate that you have passed this particular level, and then now you have access to more information, more direct access to me to ask questions. Maybe at certain levels, it's instructor led courses. Maybe it's access to more uh, online resources like here's a replicator. Go ahead and log in, start writing your apps against that replicator. So yeah, let's have some feedback from the learners and say, oh yes, this worked, and then okay, let's keep building the school, keep building the curriculum in that direction. So yeah,
Because
that's
there's so many things to know.
mm-hmm,
Um, I just realized I did open my VS Code. That
mm,
didn't work a lot, but then I realized that, for example, on the website, uh, a lot of the information, because things are getting easier, like with the replicator,
mm-hmm.
but the flip side is that a lot of information that you don't need today, you have to look it up in GitHub
Oh yeah.
from the old website. And all things that, because we went through it, there is a little memory of it,
Mm-hmm.
but somebody who comes new to it, um, he has to. The same thing with that video that you made.
Mm-hmm.
Um, I think for somebody who never heard about Jinaga, um, it's very abstract.
Mm-hmm. Yeah.
Um,
Yeah, that is true. Yeah, my hope with the history CRDT in general is that I can talk about it a little bit more abstractly. I don't have to say, and this is specifically how Janaga implements it, um,
mm,
and leave that open for others to produce their own implementations.
mm,
Yeah, I would really love to see other mathematicians, maybe actually practicing mathematicians and not just pretend mathematicians,
mm,
going um, and saying, "Oh, okay, I can build on that result, and I can create other CRDTs that have those same guarantees, but maybe some other interesting guarantees, or maybe they find that those guarantees as stated are not as good as these others, and just improve upon it in theory. So I think that can happen. Yeah, outside of the Jinaga track.
Mm.
So I do want to keep
Yeah.
it a little
Anyway,
bit abstract.
if you want it to be picked up by the scientific community,
Mm-hmm.
then it has to be a little bit mysterious.
Oh yeah.
Otherwise, they are not.
I was like, yeah, this is too easy. Yeah, it's obvious. Yeah.
Uh, no, what else? My notes here about, because I wrote down a little bit. Otherwise, I cannot.
Mm-hmm.
Uh, I don't know what the 5 minutes before were. Oh yeah, I also went back to chapter 4 in the book, location
Mm.
independence,
Yeah,
just to realize that I have to reread it. Um,
that's a pretty dense chapter. Yeah.
yeah, I even summarized it at the time, but most of the things, yeah, perhaps it's things that I've never understood at the time, but I just read over it. I don't know.
Hmm.
But now by going through, I say, what was that? What was that?
Mm-hmm.
So I say, okay, I will reread it.
Yeah. Yeah. That's a lot of the stuff in that chapter are the things that when I have a conversation with somebody, they think they already understand what those things mean, and then we get into it just a little bit more, and they realize that there's that it goes deeper, that there's more to it. So like just starting with eventual consistency. It's like, oh yeah, I know what that means. It means that you're not going to update the record. You're going to put it in a queue. And then I say, well, let's actually dig through what is it going to take for you to know that that these two systems are going to become consistent. What if I put these messages into two different queues in different orders? Can you guarantee that they eventually reach the same state? And so no, we have to think through that, um, and then they try to solve each specific problem, and it's like, okay, no, that was just an example of the kinds of things that you need to solve. You need to step back, start from the beginning, and oh, by the way, there's this big history of papers that other people have written that give you that starting point. Let's go back and review that. Like one of the things that I'm seeing, and I see this repeat every once in a while. So the event sourcing community. So they are talking about, hey, how do you have two aggregates that update from the same event? What are some good examples of systems that do that, and how you solve that problem? And so, I'm seeing people, talking about, hey, I use this solution, I use that solution, and trying to figure out, what's the best way to accomplish that. And then you take a look at Kafka, and you look through the documentation, for how to how to set up a set of Kafka topics that solve a problem, and then you always end up with the question, well, okay, if I need something to subscribe to two Kafka topics, how can I make sure that that those two are consistent with one another? Because I lose all consistency guarantees once I go beyond the boundaries of one topic. And when I look at these things, and they pop up every once in a while, and people are like proposing these edge case solutions but don't work in general, then I'm thinking, okay, you're not going back to the core problem. All of these things are the same problem, and
because the event sourcing community is always full order and not a partial order.
yeah,
So
yeah. So
yeah.
it's a collection of fully ordered uh,
Mm-hmm.
uh, event streams, and each one is on its own consistent, but
Mm-hmm.
the collection is not. And so how do you describe, and so they they're just used to, oh, well, I write a state machine that subscribes to this feed and that feed and this other feed, and then updates the state. And so how do I make my state machine consistent? And I was like, that's the hard way to go about it. Let's just take a step back what does it mean for you to want to project this aggregate? What does this aggregate actually mean? And let's write a specification. And so, finally, after all of this time, writing the book and then working on Jinaga, we finally said, oh wait, here's a specification language. It accidentally fell out of the link syntax, and it's like, that works. Okay, I can write math around that. And so the History CRDT is, I think, the first example, certainly the first one that I've seen, that has a formal definition of what an aggregate is, that then solves to how to have a consistent aggregate that subscribes to multiple feeds. And it's the trick was that you have to stop thinking about the message as an atomic unit. So you take a specification, you compute some feeds. The rows of the feeds are tuples. They're collections of messages, of facts. And so that particular collection, at some particular point in time, satisfied all of the conditions of that feed, and those conditions were derived from the conditions of the specification that generates the aggregate. So there's another layer of abstraction in there. You have to go from specification of aggregate to specification of feeds to tuples within the feeds, and then finally to the individual facts. And they're skipping at least one of those steps. I think actually maybe two of those steps, and then saying, okay, I want to get from this message to a consistent aggregate. How do I do it? So have to preserve those layers. Have to go through the math.
Yeah, it's an amazing journey to get there.
Yeah, and honestly, I can't believe that it took me this long to come up with that specification language. And now that it's in my head, when I go back to the book and I look at the pipeline diagrams, and it's like, that was the hard way to think about it. But this so easy.
I still don't understand how you found it, because it's really amazing. It's really amazing.
Well, to that end, actually, let me transition to talking about the code changes that I made since last week. So I've got inverses of the specifications working in Jinaga.js now. That's basically a port of the Jinaga.net Jinaga.net code. So let me switch to that guy.
Yeah.
And there we are. Okay. So I did this in two phases, actually kind of these two phases in parallel. So I've got the inverse spec here. So spec in this case meaning a test in jest. And then the watch spec. So let me start here. All right, so we are now doing a j.watch, but the previous j.watch, you can see all the different overloads of j.watch now. The previous was from preposition, and that was what you get from the specification functions, or what I used to call template functions, and it still has the word template function is in the help there. So got a couple of different overloads for that. But then now we've got a new overload of watch that starts from a specification. And we can get into all of the TypeScript goodness that is watch args, but we already did a whole video on TypeScript, so we'll hold off on that. Okay, so this one we start with a specification, and a specification starts with a model, so that at runtime we have all of the information about the graph, which facts are related to which other facts. So so here I'm just going to say I want to say, given a company, I want to match on the facts of type office, where the office company is equal to that company. So just a one-step successor join. And so when I do a j.watch, I'm starting with the empty company. So this is the company that has no offices. And then initially, this has no results. So I start the watch, I await initialized, and then stop it. And that list of offices should still be empty. And if I ever get one, I'm going to push its hash to this list of strings. But now here, if it previously existed, so now I'm starting with the watch company. So I'm starting with the company here that has an office. So Testco has test office. Mm-hmm. And so in that case, I expect the collection to have the hash of that office. So I've got loading in the results that are, or the facts that are already in the repository that match that specification. And then here, this is where it starts to exercise the inverses. So we watch that that company, and then we, after we have started the watch and we know that it's initialized, then we create a new office. And then when we stop it, we see that we've got these two hashes, the one that was there in the past and this new one. Mm-hmm. So how does all of that work is that I need to compute an inverse. So if I see a new office, then I want to be able to run a query to figure out which watches will care about that particular office. Mm-hmm. So I do that with an inverse. And this is the inverse that I end up running. So same specification. Starting with the company, find the offices of that company, get the inverses from that specification, and I have just this one. So starting with the office, give me the company, where I've the office's company is equal to P1, that company. And then project the office, because that's what I was projecting out of here in the first place. So it's the same projection as the original specification, because this specification right here, it will start from a company and then give me an office, because that's what I'm returning there, facts of type office. So the inverse will give me the same thing. And so that means that I can run this this query starting with this brand new fact that I just learned about. And then it's going to give me back, through this projection, it's going to give me back that same office that I just put into the query. And then I'll be able to use that projection and add it to the results of the appropriate watch. But how I figure out what the appropriate watch is that this query is actually giving me back a couple of things. Before it runs the projection, it's also giving me the tuples. So U1, P1. What are the tuples that match that specification? And so I know that the subset of that tuple, P1, is equal to the subset, the givens that I provided for this particular watch, that company. So if I got a watch from a different company, when I receive an office, I'll see that the company doesn't match this particular watch, but it does match that watch. And so I know, okay, add this result to that collection, or add it to this collection.
I don't follow there.
Yeah, so
because so actually the inverse
yeah.
we added a new office.
Yeah, so well, let's go ahead and write that that test. So so if we if we have the same specification,
Yeah.
then just as before, I'm going to say, yeah, I want to watch a particular company, and as I receive offices, add them to this collection. But then, yeah, and then I'm going to await office observer initialized. And now my my new office will be for another company. And so let's do a new office. And this is going to be in the empty company. And, oh, not new, const. And so then when I do a j.fact to add that one, I would not expect it to show up in this list of offices, because this list of offices is watching this particular company, not that company.
Okay.
And so let's let that office observer stop. And then I would expect offices to equal just the hash of the existing office, not the new office. So, so do you see why that is the expected results?
Because we are the office observer is watching for the normal company. Yeah.
Yes.
And so we initialize it. And then we make an empty company. We add a new office.
Yeah, this
to that empty company.
Yeah, and this empty company already existed, and it was already part of the model. So yeah, we've already created it up there. So that's part of the initial state.
And so automatically, because it's another company, it should not turn up.
Correct. Yes.
Yeah, but how? Okay, that's logic, but how is that gonna happen then?
Okay,
Um,
so let's go ahead and do uh, the jest on that guy, and it should pass. I hope it passes. Yeah, let's see. Expected it to have this hash, but it's actually received a whole company. Wait, no, it's received the entire office. Oh wait, expect offices. There we go. There we go. Ah, interesting. All right. Wow. There we go. There's a bug. Okay. So we expected it to have this one hash in it, and we found that it's got two hashes. So that means when I did this JDAT fact for this new office in another company, it actually ended up matching. Okay. I've got some work to do. But the reason that this is supposed to work, if we take a look at the inverse for that specification, then when I start with this office, I should pick the company that is the predecessor of that office. So this inverse will produce that tuple of U1 P1, the office and its company.
mm-hmm.
So the watch is supposed to be looking for the subset of that tuple that is just the company. And if it matches this particular parameter, then I call the onAdded. But if it doesn't match that parameter, then I'm supposed to ignore it.
Yeah.
So let's see if we can trace that through real quick. So here's some JavaScript stuff to figure out which one I'm calling. So okay, here's the new watch, and do some parameter validation. All right, so here are the references. I create a new observer, and we start that observer. So it first runs the initial query. We know that that one is not the problem. But then we add a specification listener, and on results, it's going to call this. So on result just is looking, is this supposed to be an add or remove? And there's other detail to go into here, but we can talk about that later. And if it's if this inverse says, okay, any results that you see of this specification, go ahead and add them, then it's going to call that. So the filter, well, actually, where is the filter supposed to be? This specification listener, all it has is this specification. It doesn't have the given. So yeah, I think the problem is I just didn't put a filter here on result. So yeah, this is supposed to look at the subset, and so here I've got the parent subset. That's a list of label names, and it says, okay, when you receive a result, take that subset and make sure that it matches that particular given. But yeah, that work. I never wrote that code. And so it's just saying, yeah, any subset, just go ahead and add it to any watch. So
Yeah.
clearly that's wrong.
So that's why the positive test works and the negative test doesn't work.
Yep.
Yeah.
Yeah. There we go. So yeah, I stopped my test-driven development too soon. I didn't think through all of the negatives. Cool. So let's make note of that. Excellent. Yeah, so you can already see if you when you look right here, there are a couple of other operations that the inverses could take on, and these are some of the cases that I actually did talk through in the book, although I used something much more complicated in order to get there. So if I've got an inverse that just says I need to add this, actually, you know what? Let me switch to this. So this one is it's using Jinaga.net, and it demonstrates inverses. I can't yet figure out how to get Jinaga.js running inside of interactive notebooks, now called polyglot notebooks. But we can do that with Jinaga.net and kind of see what's supposed to happen. So here we've set up the model. So we've got a president of an office is a user. And so now I can have a specification that says, okay, given an office, which user is the president of that office? So from the FACSO type president, find the presidents of the office, and then FACSO type user, find the user that is that president. So it's kind of going down to a successor and then back up to a different predecessor. So that's the specification that we end up with. And then the inverses, right now, this actually is showing something that I just fixed in Jinaga.net. So right now, Jinaga.net is saying, okay, I found two inverses. So let's basically take these labels. We've got the office, the president, and the user, and let's shuffle them around so that the other labels get a chance to be the given. So let's do one that starts at president. And then that means I need to move office down and need to take this this condition, and I need to flip it around and move that condition into the office. But then this condition stays inside of the user and doesn't change, because we've already the user is appearing after the president and the office, so so it can have the same set of conditions. But if you move two labels, you rearrange them, then you have to move the conditions from one into the other and then reverse them. So then I do that again for user, and now bubble user up to the top, and then from user, the next thing that I can get to is president. So I have to swap the user to president and make that president to user, and put that inside of the president, move that from user to president. And then I can bring in the office, and the office is already following the president from up here, so so it's that same ordering from there.
Yeah.
So just mechanically go through that process of taking each label and making that the given. So after going through that process, now we've got a set of inverses that if I see a brand new president fact, then I can run this inverse, and I can see which queries need to be invalidated. So I know that that query came from, or I know that that inverse came from this specification. And so I look for the queries that have that particular specification, but then I want to find just the ones that start at a particular office. So that's the starting point of the original query. Which of those queries were actually invalidated by this particular president? And so to find that out, I run this and get the tuple that is president office user. And then I take just the subset, just that office. And so that's going to be the office that this particular president that I just learned about is pointing to as a predecessor. So I say, oh, okay, I just learned about a president of the Dallas office, so I don't care about the president of the Calgary office or the Houston office, or those queries are just fine. It's only the Dallas query that needs to be invalidated.
Yeah.
And furthermore, I know that since this projection was this user, when I run this specification, I'll get out a user when I run that projection, and I can add that to the results. So I just say, okay, let's find that query, run the projection, add that result, and everything is up to date. So that's how this is supposed to work. And in .NET, well, no, now I'm wondering. So I'm going to have to write make sure that I've got that negative test in .NET. But yeah, in .NET that should be doing that filter. But there's this other query that it came up with, this user query. So let's think about this one. I just learned about a brand new user, and I want to figure out, does this invalidate any of my president queries? So the first thing that I'm going to do is I'm going to look for facts of type president, where the president's predecessor user is this brand new user that I just learned about. So is it possible to find such a fact?
President is the successor of user.
Exactly. Therefore,
So
it doesn't exist yet.
Yeah.
You just learned about this user. It doesn't have any successors yet. You might just on the heels of this learn about a president fact, but then this inverse is going to take care of that one. This inverse will never fire. Will never give you any useful results. And so, an additional optimization that I made just this week was to eliminate this inverse. So any inverse that refers to the this side, that refers to the given, and doesn't have any joins on the given side, but it does have some joins on the on the other side, the unknown. Then I know that is looking for successors. It expects this fact to have successors. So if it finds any matches with that kind of condition, it says, oh, this is unsatisfiable. Let's just eliminate this one.
Of the old optimizations described in the book.
Yeah, that one is described in the book.
If you can only start from the valleys and not from the tops.
Yep, exactly. So we're still seeing that one because I just added Jinaga from NuGet, and I haven't published the fix to NuGet yet.
So it will automatically leave that inverse query out then, and just only process the first one.
Yes, exactly.
Okay.
Yep. Which as a human, that's what you would do. You would say, oh, okay, I'm building this model, and so I know that I need to invalidate that query whenever this thing happens, so I'll subscribe to the precedent fact or a message, and then I will figure out who that user is and add that to that queue over there, or to that projection over there.
Mm.
As a human, you would never think to write this one.
Yeah.
So let's let Jinaga be at least as smart as the humans, and probably
Okay.
no smarter.
And a lot faster.
Mm-hmm. Yep, yep, and automatic, so that you can deploy a brand new version of your mobile application that has new queries in it, and
Mm.
your replicators just see those new queries and know what to do with them. With the edge case of, or not edge case, with the exception of distribution rules, which we will definitely have to get into, but I've not yet implemented distribution rules.
Yeah, Michael. But is there a kind of automatic removal of queries from the replicator then?
Mm.
My application, I upgrade my application. Some of
Mm-hmm.
the old queries are not valid anymore. Or do I? How does the replicator? He knows all these queries
Mm-hmm.
to do the feeds. Is there a timeout? Do I have to renew them regularly?
Yeah, that fortunately um, the removal of queries doesn't have to follow the same rules as the removal of facts. So so yeah, you're now back in the world where you can yeah, you can remove things and then let it rebuild. So yeah, to answer your question specifically, um, uh, if you if you take a look at the Jinaga server, the way that it comes up with these feeds is that you get a query from your client, and then it calculates the feeds, and then it gives you back hashes for those feeds, um, and it's going to cache that those feed specifications, so that it knows when you then make a call for that particular hash, it says, okay, I know what the specification is, I'm going to run it and give you the results. And it just keeps that in memory. If you were to just restart the replicator, then it wouldn't know what any of those feeds mean anymore. So if a client comes in and says, hey, give me the results of this feed, gives back a 404, the client would say, oh, okay, you've forgotten. Here's the specification. Give me back the list of feeds, and now they're cached, and then it'll ask again. So the way it's currently implemented, just as you restart replicators, then they will age out. So you can add to that the timeout mechanism that you're talking about. And then furthermore, if the feeds are backed by some persistent queue, like inside of the replicator, we actually put a Kafka topic or a RabbitMQ queue. And so every time you see a specification, then you actually create those queues, and then you assign them the hashes. And now you're running the inverses. That's what we talked about at the end of the last video. So you run the inverse, figure out which queue needs to we need to insert a new tuple into based on this this inverse, and then now when the client calls in and says, okay, give me the tuples from that feed, it's just immediately loaded from Kafka or whatever. So so in that case, there is some physical cleanup that needs to happen. So so then you can have some some timeout that is looking at like I've got this I've got the time at which each of these feeds was most recently accessed, and then once it's like 2 weeks old, a month old, whatever, and then I'll just go ahead and destroy that entire Kafka topic or RabbitMQ and clean up all that stuff, and knowing full well that if the client really is just on holiday and finally comes back, then we'll recreate that, and they can pick it up from there.
You recalculate the inverse and rebuild the queue.
Yeah. So that is all possible. So nothing that we're doing today is going to keep us from doing that in the future.
Okay. Well, that are all practical things. Once you start implementing it.
Yeah. Yeah. This is kind of so when people are talking about building distributed systems, they immediately jump to the practical questions. And that's kind of what I was saying earlier. Is like let's take a step back. Let's think about the theory first, and then once we build that, then we can get back to the practical questions, and we have answers for all of those things.
Mm-hmm.
I mean, like my favorite practical question that I receive just about every time I talk about this stuff is, hey, doesn't this mean that your data is going to just grow unbounded, and you're going to have all of this code or all this data sitting around that you're not using anymore? And it's like, no, we've started with that theory. We know how these things are going to converge, but now if you build into your model a query that you no longer after a period of time you're no longer going to be looking at, then now I actually have the formal language for it. Then what you're doing is you're evolving your replica to a subset. You're evolving it to the evidence for the queries that you do care about. So yeah, the easy way to do that is to just take this replica offline, put another replica. Well, you don't take it completely offline. You put a new replica in place, and then have it point to that old replica, and then queries come in.
Just run the new queries.
Yeah, and it's gathering evidence, and then you put that one on cold storage, and then you put a new one in place, and you just kind of keep popping these things through. And then if your model is implementing the period pattern, then you know that you're going to be getting new queries for new periods, and you're not going to be interested in the old periods anymore, and those will just go into storage.
Yeah, indeed.
And I get to wave my hands because I've already done the math to show that that's going to work.
Because there you might have two layers. The cold storage, which is a second layer. If ever you need to go back that far, you can always access it.
Yeah, exactly. Yep. And so, keep looking at Jinaga.com. There will be a login page there where you can say, hey, I want to create a new replicator. Hey, I want to design a model. I want to put the replicators together in this topology, and then I want to to implement this cold storage pattern and move things into cold storage once a month, and then just let it do all the infrastructure for you.
No, and the subset pattern is very useful in case of mobile applications. Because with the original system, you needed all the data in your mobile phone, which is not going to happen for a very big application.
Right, yeah. So yeah, when you start up the mobile app, it says, "Oh, look, it's been it's the start of a new month. So hey, let me just go ahead and create a new database in here, and sync you up with the old database, and then your database from a couple of months ago, we're gonna let that one fall out. So we'll clean up that storage, and then if on your mobile device you actually do navigate to old data that's no longer on your device, then it's issuing that query to the server, and that data comes back again. But most of the time, you just let it roll off the phone.
Yeah, you could keep an old small database on the phone, the last month's database, and use that as backup storage.
Mm-hmm.
And indeed, if we need something that is not in last month and not in the current month, we go back to the server.
Yep.
Okay.
Yep. Best of both worlds. It's still offline, and you're
Mm-hmm.
cleaning up data.
Indeed. Um, and that was my question from long
Yeah.
ago. How do we do that?
Yes. Well, you
Well,
needed these
here is
tools
the
in order
answer.
to do it. Yeah.
Yeah, yeah. That's great. That's great.
All
Okay.
right.
Um, what is it? Icon flashing here. Oh no. Let's see. Discord has a green icon in the tray now. I never saw it, but
Hmm.
and it's flashing. I don't know why, but yeah, it's flashing each time one of the windows takes focus. That's it.
Oh, okay. Is it related to who's talking?
Yeah,
Because
I
there's a
think
green
so.
outline for each of us as we talk.
Hmm. If I make noise, it's green, and if if you make noise, it doesn't show up.
Oh.
Hmm.
Oh, okay. Wonder why it's
I don't know
why it's
why.
doing that.
Never
Anyway.
saw it. Good.
Very good. Well, now I've got a bug to fix. So next time I'll show that the bug is
Hmm.
fixed, and um, then yeah, there are some other there are some other edge cases with related other optimizations that can be made with inverses. So I think I will probably keep going down that path, um, and then if you've got some progress on the SQL path, then we can go over that. I think that after, so I'm gonna be on a cruise for the first half of January, so
Okay.
there won't be yeah, we'll skip at least 2 weeks in there. Yeah, I think it'll just be 2 weeks that we need to skip. Maybe three is how it's going to work out. But uh,
You don't take your Starlink on the cruise.
no, no. That's the whole point of the cruise is that, oh, you know what, Wi-Fi is really expensive. Sorry, I can't connect.
Yeah.
but um, but yeah, so when I get back from there, then I can start focusing my attention on the Jinaga.net SQL storage, and so then
Mm.
if you need some help at that point, then I'll jump in.
Well, I should finish it at that time. I hope I hope by that time.
Mhm.
No, yes, today and tomorrow I will still be catching up, but I hope after the weekend I can put some time in it. I hope so. Then it's anyway over here it's holiday time for most of the companies,
Hmm.
so they
Oh,
will leave
okay.
me a little bit
Nice.
alone. I think. Um,
Yeah, so this will be your holiday hack.
yeah, and I think only one of the three children is coming home, so
Oh,
there should be some time.
yeah. Yeah, but
Let's see.
it's always better to see the children anyway.
Yeah, but if they are going well, then I'm happy with it.
Hmm.
So next week, Michael, you will be there?
Yes, yeah, I'm still here
Okay.
next week.
Okay.
So then I will see you at that time.
Okay. See you next time then.
All
Next
right.
week.
Thank you.
Okay. Bye.
Bye.